I know we have buildings that are performing and buildings that are not performing. So within the association, I take that back to how do we make buildings work better by having better materials. And the only way you know whether the material works or not is to do the testing. The tests that we run right now are way below what they're going to see in many cases in the field.
ASTM E331 is a test method that tries to determine the effectiveness of a wall assembly to resist water under differential pressures.
Some folks are going to go, oh, it's a 30-mile-an-hour wind. And some people will take a step back and go, okay, but what else? Oh, there is nothing else. We passed an industry standard. We got our stamp of approval. Okay, some will go, might want to go up a little higher. We do that in a contained box. The machine itself, in its simplest form, builds pressure. The concept is derived from E1105, which is a field test. Hang a spray rack off a building, put water on it, and then draw negative pressure from the inside of the building. In the window test that we provided for a client a couple weeks ago, the goal was to find out where the glass itself would break, basically.
Watching the test to give its pressure against the window, it was really interesting for me because I saw physically how the window reacted, how the glass bowed, how the frame started to twist. And of course, the big interest is when everything blew up and we had glass all over the place.
20 is 203. It's dropping up. It's at 22.6, 23, 2360, 2380, 24, 26. Yes!
We took that window up to over 5,000 pascals, or 220 miles an hour of wind pressure.
With the chambers, we're able to demonstrate those visual, compelling statements of building failures that are going to question the industry standard to say, is this too low? You know, is the threshold so low that anyone can pass? And, you know, people don't even know. There's a stamp on it that says it's great, and most people are like, well, it has a stamp.
The standard is the minimum benchmark that everybody agrees to.
As we're developing standards, we can do two ways. We can start from the bottom and go up. We start with all the materials, or we can do a whole building for thermal performance and moisture management and so on and so forth, and work our way down. And how do we test so we have an idea if we put this wall assembly, this roof assembly together, it's actually going to work as intended.
Industry standard is not enough. Industry standard is on a nice, warm, sunny day that you don't have to wear, you know, too much sunscreen. Imagine spring. Why is that important? Because buildings and the behaviors of buildings are not understood. And the industry thinks that every day is a spring day.
A machine like this that we've been studying for the last couple days is the kind of equipment that will point to materials that can be flooded, they can be dried out, cleaned off, and put back into service without disassembly. And as we do that, the indoor air quality and the cost of owning and operating and maintaining a building is addressed, and indoor air quality is addressed. Kids in school get better grades when the indoor air quality is better. People are in better moods. People just have a higher quality of life if they're living in healthy buildings. And that's very important to me personally and to us as an organization.